What's up, everyone? Yesterday we were covering like the basics of optimization. Today we're covering more advanced optimization, and to be real honest, like this unit is a really quick unit. It's really just in kind of an application of the last unit, short and sweet application. So I have this kind of like cardboard square that I have, and I want to kind of like how should I say this? And I want to make a box out of it. How can I get the most volume out of my box? Again, we're talking efficiency here. How can I get the most out of this box that I'm out of this kind of like cardboard that I bought from the store? And I want to make the box. Well, volume, as we know, of a rectangular prism is LWH. So, so that would be length. There's XX, so this is 12. So we get 12 minus 2x times 12 minus 2x. And in the height, this is going to be folded up, so we're going to get x. Now we go 144 minus 48x squared. So what we really end up getting, v 4x cubed minus 48 squared plus 144x. v prime then becomes like 12x squared minus 96x plus 144. So then x critical numbers become like 2 and 6. Is it? Yeah, it's 2 and 6. Now here's the thing. 6 is kind of an endpoint. Because if x becomes like even 6, then we don't have a box. Because you basically just kind of cut out everything. But if x is like, but 2 isn't a domain. Domain 0, 6. Inclusive or exclusive, well, that depends on you. But 2 is in that domain. And I need you to show me that 2 is a maximum because we want to maximize the volume. So let's plug in 1. We get 12 minus 96 plus 144. So that's going to be 156 minus, that's 60. So at x equals 1, we get a positive derivative. Now let's test like 4. We get like 192 minus 384 plus 144. We get negative 48. So that becomes a negative derivative. So v prime goes from positive to negative at x equals 2, which means, that means the volume is maxed out when x equals 2. And what is a volume? It's like 8 times 8 times 2. So that gets us 128 cubic units. There, not bad, wasn't it? Now, let's do another problem. I have this kind of box, I guess, or like I want it to be 120. No, not 128. I like the number 192 cubic inches. And let's say the width, and I want a square base. If it wasn't a square base, the problem would be much harder. And then I have height, because I like squares. Let's say that, and it's gonna be in a closed box. Well, here's the deal. 192 is w squared h, right? Because 192 is our volume, and then you have square times height. Base times height. Surface area, however, is going to be 2 times w squared. Plus, we have a w times h, w times h, w times h, 4 wh's. Now, we're going to set this to 0. But here's the problem. I see 2 variables right here at the 4wh. We're going to have to make it 1 variable. But don't worry. We can. And we're gonna do just that. So get ready. H is 192 over W squared. 2W squared plus 768 over W equals 0. And that's the surface area. No, that's surface area. Now we need to take the derivative of surface area, which is 4W minus 768 over W squared. That's 0. And then we get like 4W cubed equals 768. And then we get W cubed is 192. And then, yeah, we get W is like 4 times the cube root of 3. Right there. So W is 4 times cube root of 3. Well, if you keep going on, you're going to see that H will also be 4 times the cube root of 3, which might be some kind of coincidence, I guess. Oh yeah, because I did a closed box, so best way to minimize surface area is just a cube, actually. Should have done the open box, but whatever. And if I find a surface area, we're going to get like 2 times W squared, which is going to be like 32 times the cube root of 9 plus 4 times 60. We're going to get like 64. So we're going to end up with 96 times the cube root of 9 as our surface area. Oh wait, and yeah, plot the number line like we always do. Show that cube root of 192 is a max. So when W is, it's a min. So when W is 1, we get like 4 minus 768. When W is less than this irrational number. And then when W is 10, we get like 40 minus 7.68 or something. And we get a positive if W is greater than the cube root of 192. But you're going from negative to positive. The surface area prime is going from negative to positive. If you're negative on the left but positive on the right, you see a U shape. And then you see the minimum at the cube root of 192. Meaning, this is a minimum. So yeah, I'll leave you there. And that's literally all I've got for optimization. It's not going to be every single little bit of detail I'm going to give to you, but I think I did as much as did like decent amount while not trying to eat up all your time. And yeah, because this is my last derivatives video, just want to put this slide for you guys. We're at the end of derivatives, which is basically just part 1 of this course. Next video is going to be about integrals, which is very applicable to daily life. We're going to use that for geometric figures. And we're also going to use that for a little bit of physics. And yeah, everyone, please like and subscribe to my channel and my swim channel also, because I post some good swim stuff there if you're interested in joining swim team. And also give feedback in the comments section below. What did I do well in? What can I do better in? Because I'm always looking forward to feedback. We all need feedback to get better, as we know. So I would really appreciate it if you did give me some good feedback. And yeah, just thank you everyone for keeping up with me. It's been hard to learn how to use all this technology, but I'm trying to get used to it, and hopefully integrals is a smoother journey. See you in Unit 5.